A very good afternoon to all of you. So here we are going to evaluate or start a new unit of this subject, which is termed as the electromagnetic field theory. So before proceeding with the lecture, I would like to explain that what is the importance of studying an entire syllabus or entire course on the topic of Emft. Exactly why we are studying this topic. This is of prior importance. Okay. So what I want to conclude or what I want to elaborate is that whatever form of energy that we are consuming, okay, if it has even a slight bit of electricity or electric field in it, okay, and if the electric field is varying in nature, okay, if the electric field is varying in nature, then that varying electric field will automatically give rise to a magnetic field. Okay, so I think this is quite clear that both the variation of electric field and magnetic field are dependent on each other. I think this is quite clear. Now, if we move further from that thing, then we all know that electric field and magnetic field are vectors. Okay, so the evaluation of vectors become an integral part. That is, we have to understand what exactly a vector is, okay, how the calculations involving vectors are performed. So from this part, I would like to shed some light on what a vector is. So a vector is a physical quantity which has both magnitude and direction. So from this we can conclude that as electric field itself is a vector, so it will have a magnitude and also a direction. Okay, clear? I think this is very much clear. Now, a vector basically is something which will broadly explain the physical quantities. It means if a vector is obtained, then we can obtain the curl of a vector, we can obtain the divergence of a vector, we can obtain the gradient of a vector. Okay, so these various operations which can be performed on vectors. Okay, second thing is that the vector knowledge, the knowledge of vectors will enable us to give us a sense of direction. Yes, a sense of direction is very important. Okay, so a sense of direction can only be obtained from a sound knowledge of vectors. I think this is quite clear. Now, before proceeding with the details, the basic intricacies of a vector, I would like to explain one more thing, that the addition of vector, as it is having both magnitude and direction, so the addition subtraction of vector will not be a algebraic identity. It has to involve phase. Okay, so the phasor addition or the knowledge of phase should be very much clear to all of us. Okay, now I will like to shed some light that, have a look at this. This particular stanza I would like to elaborate. This particular line. To recognize a scalar and a vector, it is standard to address a vector by a letter which a bolt on top of it. Okay, it means that we have to put an arrow on the top of vector so that it is represented its representation is complete. Okay, whereas a scalar which is only having a magnitude but not a direction. Okay, for example, take the case of mass, the mass in a body. So the mass in a body is basically only having a magnitude. If it is 10 kgs or it is 20 kgs, that's it. But if we are concerned about weight, so weight automatically comes into category of vector. Clear? Okay, now moving forward. Okay, I think the basic difference between a vector and a scalar is quite clear. Now I will like to scroll a bit, and now we come to the unit vector. What exactly a unit vector is? So basically unit vector will enable us to find a direction. Yes. Okay. Many operations which are carried out on vectors involve projections, gradient, divergence. Okay, so in all these operations we have to obtain the particular unit vector. If the unit vector is not complete, if the unit vector is not obtained, then we cannot perform even the basic operations like dot product, cross product. So the magnitude of a vector is basically a scalar. Yes, because it is only having a magnitude, it won't have a direction. The unit vector of a vector comprising of ax, ay, az is given by the vector itself, that is a, as it is quite clear from here. There it is a divided by mod of a divided by mod of a, so it comes out to be a cap. It comes out to be a cap. I think this is quite clear. So a cap is nothing but the magnitude of vector. I think it is quite clear. Now unit vector. So unit vector will specify us the direction. Now come to another part, that is this part. Now a very important conclusion can be drawn at this point of our discussion, and that conclusion is that the magnitude of unit vector is 1. Okay, so a unit vector will have the magnitude that is 1. Okay, I think this is quite clear. Now this particular statement, that is this, that's it. Here you can observe that the component ax of a, the component ay of a, and az of a is represented, you can see, with its constituent unit vectors, that is ax, ay, az. Okay, so this is nothing but the vectors having different components in unit vectors. Okay, I think this part is clear. And as the unit vector is here, the discussion is going on, so this is an apt time to discuss various other components. For example, in the rectangular coordinate system we have rho, phi and z. Okay, is it clear? Yes. So rho cap, phi cap and z cap will be the unit vectors which will decide the calculations. Okay, similarly in the spherical coordinate system we have r, theta and phi. Okay, so what I wanted to convey is that if we don't understand what exactly a unit vector is, then we won't be even able to understand the basic coordinate systems, and this will be an issue for all of us. all of us. Okay, so in the next lecture I will continue my discussion on the different vectors. Okay, thank you for having me on this lecture and have a fantastic day.